Venus was once an Earth-like planet. It had an atmosphere similar to ancient Earth, substantial water on its surface, and probably even life at some point in its history. All this sounds impossible because if you look at Venus today, you'll find quite the opposite. The planet has an atmosphere that's 96% carbon dioxide. It's so thick that no sun rays can reach the planet's surface. The average surface temperature of Venus is 460 degrees Celsius, hot enough to melt lead. The landscape is full of active volcanoes, and to make matters worse, it rains sulfuric acid in its upper atmosphere. But what went wrong with Venus? How did the planet change to hell from paradise? Finally, and most importantly, is present-day Venus the future of our planet too? The most straightforward answer to all these questions is volcanism. If there existed simple life on Venus, volcanism was its doom. We know that volcanoes are violent, dangerous, and unpredictable. They may appear visually intriguing, but are mostly the epitome of disruption. And in the case of Venus, they have been the primary driving factor behind the planet's demise. We can't have a direct view of Venus's surface because of its dense atmosphere. However, in the 1990s, when NASA's Magellan spacecraft produced a radar map of the planet's surface, it found something intriguing. The map revealed that almost 80% of the surface was covered in volcanic basalt rock. Such rocks are also addressed as large igneous provinces, or LIPs. They result from periods of large-scale volcanism lasting tens of thousands or even hundreds of thousands of years. In the case of Venus, LIPs have resulted from tens of thousands of years of volcanic activity. According to a recent study, several volcanic eruptions occurred on Venus in just 1 million years. That sounds like a long time, but it's just a short period in the 4.6 billion year history of the planet. Each volcanic event spewed lava that covered hundreds of thousands of square kilometers. This collectively added so much carbon dioxide to Venus's atmosphere that its climate could not withstand it. The carbon dioxide-filled atmosphere prevented the planet's heat from radiating into space. With no way to cool, the temperature soared to extreme levels, like a greenhouse with all its vents closed. Eventually, this runaway greenhouse effect transformed a wet and temperate planet into a scorching world. The increasing temperature would have boiled the oceans away, adding water vapor to the atmosphere. Since water vapor is also a greenhouse gas, this would have accelerated the runaway greenhouse effect event at a large scale. Over the years, all the water would have been lost to space, and the only thing that remained was an inhospitable world surrounded by a carbon dioxide blanket. Even on Earth, volcanism has always been a big deal. Life on our planet has witnessed robust, sustained volcanic activity. For example, there have been 5 major mass extinction events since the origin of multicellular life about 1 billion years ago. Each of these events wiped out at least 50% of animal life across the planet. Most of these extinction events have been fueled by some eruptions that produce LIPs. However, in Earth's case, life has always recovered. The volcanoes never caused a runaway greenhouse effect, and there are multiple reasons behind that. First of all, Earth has a plate tectonic system. It allows heat from the interior to reach the surface by periodically opening the mantle blanket. On the other hand, Venus lacks such a plate tectonic system, aggravating the situation. Secondly, the scale and extent of eruptions on both planets have been quite different. Although it's unknown how often the events that created these inhospitable conditions on Venus occurred, researchers have tried to narrow down these estimates by studying Earth's history. To do so, they performed random simulations to recreate Earth's volcanic past. In one of the approaches, they approximated the rate at which sets of near-simultaneous LIPs occur to be statistically the same as Earth's. They found that LIPs closer in time then 0.1 to 1 million years are likely. However, it is significantly less than the time over which terrestrial LIP environmental effects are known to persist. So what exactly happened was that different LIP events overlapped one another. This means that before the planet could remove the carbon dioxide released into its atmosphere from one event, another was already on its way to bombard the planet with more greenhouse gases. The longer an event lasted, the more chances it had to overlap with the following one. The probability of the largest LIP in Earth's history overlapping with a similar sized event was found to be approximately 30%. However, with the planet able to exchange carbon dioxide and other greenhouse gases between the mantle and the atmosphere over millions of years, Earth had a narrow escape from a deadly runaway greenhouse scenario. But for Venus, with no such mechanisms at work, it likely suffered overlapping at a much larger rate that led to its ultimate doom. Scientists are still determining the exact chain of events that transformed Venus. Several missions are being planned on these lines, with Da Vinci and Veritas scheduled to launch in the late 2020s. One of the primary goals of Da Vinci is to narrow down the history of water on Venus and to figure out how it may have disappeared. This will indirectly provide more insights into how Venus's climate changed over time. On the other hand, Veritas is an orbiter designed to investigate the surface and interior of Venus. This will help us understand its volcanic history and the transition to its present state. The data from both these missions are expected to decode how exactly Venus transitioned from being a potentially habitable planet to a dry and sweltering world. In addition, it can also contribute to studying the Earth's volcanism, how it has affected life so far, and how it may continue to do so in the future.